Third video is Pythagorean identities. So if we know the Pythagorean theorem as a squared plus b squared is equal to c squared, right, side c would have to be the hypotenuse. If we think of that in terms of a unit circle and drawing a triangle from the unit circle with its vertex at the origin, you could think of it as x squared plus y squared is equal to r squared, right? So this would be a quadrant 1 angle, goes right and up. X squared plus y squared, right? X and y are the two legs, r is the radius or the hypotenuse. So you have x squared plus y squared is equal to r squared. So what we want to do is relate this in terms of sine and cosine and even some of the other trig ratios that we have. But the first Pythagorean identity is just going to use sine and cosine, right? So in terms of the unit circle, right, we know that sine of theta, right, any circle or any angle would trig y over r, right? But if you think of it in terms of the unit circle, we have y over 1 because the radius would be 1. So essentially sine of theta is just y, cosine of theta is just going to be x. Great. So if you can think of x as the same thing as cosine of theta, y is the same thing as sine theta, you can essentially just replace x with cosine theta, y with sine of theta, and that creates your first Pythagorean identity. So our first Pythagorean identity is actually going to be very simply we'll do x first, but it doesn't really matter. Cosine squared theta plus sine squared theta, right? We put the squared before the theta because we're not just squaring the angle. It's like cosine of theta times cosine of theta. So we do cosine squared theta. And that's pretty much it. And this is commutative. It could be sine squared theta plus cosine squared theta, which you might see it that way. You could rewrite it, if you subtract cosine theta or cosine squared theta, or if you subtract sine squared theta, you can rewrite this equation in different ways. And you want to be comfortable with those ways, but that's essentially the first Pythagorean identity. And there are two more, which we'll go through the first one. And actually, the third one's given to you as well. But second one, the second Pythagorean identity is 1 plus tangent squared theta is equal to secant squared theta, right? And it's basically just derived from the exact same Pythagorean theory that or identity that we did, right? Because if I take sine squared theta plus cosine squared theta equals 1, I can divide both sides by cosine squared theta, right? If I divide both sides by cosine squared theta, it should be quick if I do it this way. Divide by cosine squared theta and divide by cosine squared theta. You can kind of see where I'm going with this, but basically sine squared theta over cosine squared theta is just going to be tangent squared theta, which we had done in the second identity. Cosine squared theta over cosine squared theta, that just cancels. It's just going to be 1. And then 1 over cosine squared theta, right? Reciprocal identities, but 1 over cosine is just going to be secant squared theta. So, I mean, some of those identities you might not have gotten to yet in the video, but you can kind of make sense of it once you get there. So what I want you guys to do now is just prove the third Pythagorean identity. So I'm giving you the identity. I want you to prove it using the first Pythagorean identity and just kind of see how the two are actually the same thing.